For decades, NASA's vision for returning to the moon relied on massive government rockets, towering machines like the Saturn V, built with the combined effort of thousands of engineers and a vast network of contractors. This traditional approach, while historic and awe-inspiring, was also slow, expensive, and tangled in bureaucracy. By late 2025, repeated delays and ballooning costs had left NASA's Artemis program struggling to meet its ambitious goals, opening the door for a new contender, SpaceX. While the world watched NASA, SpaceX quietly drafted a bold, independent plan to return humans to the lunar surface, bypassing much of the government's aging infrastructure and red tape. This isn't just a paper dream. After a string of dramatic, high-stakes test flights, some ending in fiery explosions, others in triumphant landings, SpaceX's Starship has finally achieved successful launches and landings, shifting the conversation from science fiction to engineering reality. Now SpaceX is positioning itself as an end-to-end provider for lunar exploration, offering not just rockets, but a complete transportation system from Earth to the moon and back. The motivation? It's partly SpaceX's relentless drive for efficiency and reusability, turning what was once a one-way trip into a round-trip journey, with rockets that can fly again and again. But it's also a direct response to NASA's slipping Artemis timeline as the agency faces mounting challenges and public scrutiny over missed deadlines and rising costs. With political pressure intensifying for a lunar landing before January 2029, SpaceX's message is clear. If the old plan is too slow, we have another way, one that's faster, more flexible, and less dependent on government schedules. Their new architecture represents a philosophical shift, favoring a mass-produced, reusable transportation network over bespoke, single-use systems that are costly and time-consuming to build. SpaceX is betting that a fleet of reusable starships, not a single government flagship, is the fastest and most sustainable way to the moon, enabling frequent missions, rapid iteration, and lower costs. The race to the moon has a new, very serious contender. SpaceX's audacious gambit is reshaping the future of lunar exploration, and the world is watching to see if they can deliver on their bold promises. The next chapter in lunar exploration is being written by those willing to move fast, take risks, and break the mold, pushing humanity closer to the moon than ever before. The brilliance of SpaceX's plan is its simplicity. Instead of relying on a patchwork of different vehicles and agencies, SpaceX has designed a mission architecture that is direct, elegant, and unified under one vision. It skips NASA's SLS rocket, Orion capsule, and Lunar Gateway entirely, avoiding the complexity and cost of coordinating multiple systems and launches. Instead, a crew-rated Starship launches atop a super-heavy booster, stripped of unnecessary mass for maximum efficiency. Every component is optimized for the mission, reducing risk and increasing reliability. Once in low Earth orbit, the mission's most ambitious phase begins: orbital refueling. This step is crucial, allowing Starship to carry enough propellant for the long journey to the moon and back. A series of Starship tankers rendezvous and transfer propellant, prepping the lunar Starship for its journey. This in-space refueling is a game-changer, enabling deep space missions with a single launch from Earth. With full tanks, Starship fires toward the moon, enters lunar orbit, and lands vertically using its Raptor engines. The entire landing sequence is automated and precise, showcasing SpaceX's advanced technology. The crew lives and works out of Starship, using an elevator to reach the surface. The spacious interior provides room for experiments, living quarters, and all the supplies needed for extended lunar stays. For the return, Starship lifts off and docks in orbit with a waiting Dragon capsule, launched separately. This modular approach adds flexibility and safety to the mission. Astronauts transfer to Dragon, which safely returns them to Earth. The proven reliability of Dragon ensures a secure journey home, closing the loop on a seamless mission. The Starship remains in orbit, ready for another mission, demonstrating true reusability and long-term sustainability for lunar exploration. It's a streamlined, reusable system. One vehicle, one company, one vision. SpaceX's direct approach could redefine how humanity explores the moon and beyond. SpaceX's plan isn't built from scratch. It's the result of 2 decades of relentless iteration, learning, and bold experimentation. Every mission, every test flight, and every setback has contributed to a foundation of hard-won experience. The Dragon capsule, now a proven workhorse, handles crew return with flight-tested reliability. Its repeated success in safely ferrying astronauts to and from the International Space Station has made it a cornerstone of SpaceX's human spaceflight program. Automated docking? SpaceX has performed dozens with Dragon at the ISS. Adapting this to Starship Dragon is a manageable leap, not a gamble. The company's expertise in autonomous rendezvous is already proven in orbit. Starship itself benefits from lessons learned with Falcon 9, rapid reusability, propulsive landing, and constant improvement. Each Falcon 9 landing has refined the technology that now powers Starship's ambitious goals. Recent soft landings of both Super Heavy and Starship are the payoff from years of data-driven development. These achievements demonstrate SpaceX's ability to turn iterative testing into real-world capability. Even the ambitious orbital refueling phase builds on existing rendezvous and docking expertise. SpaceX is extending its proven track record to new, more complex operations in space. SpaceX is assembling a lunar transportation system from mature, flight-proven components, integrating technologies that have already succeeded in the harsh environment of space. It's not about inventing everything at once. It's about connecting the dots between technologies already flying and building on a legacy of real achievements. This modular, experience-driven approach makes the timeline plausible and the mission real. By leveraging what works, SpaceX is turning the dream of lunar exploration into a practical, achievable reality. SpaceX's independent proposal and NASA's Artemis architecture are studies in contrast. SpaceX's plan is vertically integrated, 2 launch vehicles, 2 spacecraft, all managed by one company, fewer interfaces, fewer points of failure, and a clear chain of command. NASA's Artemis, by contrast, is a patchwork of legacy hardware, international partners, and multiple contractors. The mission involves SLS, Orion, Gateway, and a separate lander, each managed by different teams. This complexity creates a logistical puzzle and a fragile chain of dependencies. SpaceX's plan requires many tanker launches, but delivers a single, massive vehicle to the moon. Artemis needs fewer launches, but involves multiple deep space dockings and crew transfers. Delays in any Artemis component can halt the entire mission. SpaceX's streamlined approach is a direct challenge to the old, complicated model. Critics like Dr. Robert Zubrin call Artemis vendor-driven, a patchwork built to keep legacy contractors in business, not for efficiency. The SLS rocket is expensive and slow. Orion is capable but costly. Requiring all these elements to dock with Gateway before lunar descent adds risk and delay. This isn't how you design a lunar program from scratch. It's the result of political compromise. By contrast, Apollo was a unified system built for a single goal. SpaceX's proposal is a direct challenge, a single provider, reusable solution focused on speed and cost. The debate is clear: grand government coalition or lean commercial provider. The lunar race is now a geopolitical contest accelerated by China's rapid progress. China plans to land taikonauts by 2030, and every Long March launch brings them closer. U.S. delays are now seen as a threat to national prestige. In response, NASA has demanded faster plans from SpaceX and Blue Origin, aiming for a landing before January 2029. China's methodical, state-driven approach is proving effective, even if their tech isn't as advanced as Starship. The U.S. is now open to whichever provider can deliver first. The race is about more than pride. It's a test of which model delivers results. The moon is the proving ground for the future of space exploration. The new lunar race unfolds in an increasingly hazardous environment. The recent Shenzhou 20 debris incident highlighted the fragility of our orbital infrastructure and the urgent need for global cooperation. The U.S. leads in tracking space debris, but gaps remain, especially with limited data sharing from China. The incident has renewed calls for universal docking standards and binding international regulations on debris mitigation. Space is no longer an unregulated frontier. Sustainability is now essential. Competition drives innovation, but safety and stewardship demand cooperation. The path to the moon must be paved with trust, transparency, and shared responsibility. Humanity's future in space depends on working together to protect the environment we all share.